This is February-March 2025, paper 1-2. The first question is, what is meant by accuracy of the measured value? The accuracy deals with the fact that are you going to get the correct answer or not. So it's just a binary answer, yes or no. So the value of G we know is 9.81. If you carry the experiment in your laboratory and you get a value of G as 9.7, slightly low, or 10.3, which is slightly higher than the correct value, then we know that these are incorrect. So this is what we mean by accuracy. It's going to be a yes or no answer. Do we get the correct answer or are we not getting the correct answer? It is as simple as that. So that is how you define this. That is how you write an answer for this. This is the threshold for the grades. If you want to get a good grade, then these should be your targets. And if you're attempting this at home, you should be able to get these marks for those respective grades. All right, so the density, he wants us to show that the density of the cube A is this. So density is equal to mass divided by volume. The mass is given as 31.3 grams and the sides are 1.53 centimeters. Now be advised that the density, final calculated density is kilograms per meter cube. So mass is going to be 31.3. I can divide this with 1000 or just simply write down the prefix for kilo or inverse kilo. And since it's a cube, I will have to multiply these lengths 3 times. So it's going to be a cube. So this will be 1.53. into 10 raised to the power minus 2 because I want to convert centimeters to meters because it's meter cube. And then I take the cube because it's a cube of uniform sides. So this will be multiplied with itself 3 times. When you write down the final answer, it's going to come out as 8739.16. Now, since I take full values, your answer might slightly differ in a few decimal places, but we have successfully shown that this is 8.7 into 10 raised to the power 3 kilograms per meter cube. This is what the examiner wanted us to show. Calculate the percentage uncertainty in density of the material cube A. Now, the absolute uncertainties are also given to you. We are going to use the formula for density because densities, uncertainty is required by us to be calculated. So this will be the error in D divided by D equals to the contributors of the formula. So this will be delta M divided by M plus, it could be delta V divided by V. But since we know this volume is calculated by this length being multiplied by 3 times with itself, it can be written down as, or instead of this, we can write down as 3 into delta L divided by L. Why are we doing this? Because the volume or the formula of volume is L multiplied by L multiplied by L or LBW, whatever variables you choose to do with this with. So since this is being multiplied 3 times with its own self, this will become L cube. And the formula for the power rule is that the power comes out, which becomes 3, and then you write down error divided by the true value. So instead of this, what we can do is rewrite the formula in the current situation, which will be delta M divided by M plus 3 times delta L divided by L. Now, once you replace values in this, then it becomes easy. And since we're trying to find out the percentage, the whole bracket has to be multiplied with 100. Now let's replace the values and we'll write down the answer directly. So this will be delta D divided by D equals to the change in, or the error in mass divided by mass. So this is the 0.5 divided by 31.3. So this will be 0.5 divided by 31.3 plus 3 multiplied by 0.01 given in the table divided by its measurement 1.53, and don't forget that this whole has to be multiplied with 100. So the percentage uncertainty in D, or the calculated value of D, comes out as 3.55%, which will be written down as 4 because errors generally are in one significant figure. The density of the material of cube B is determined to be 9.2 with an error of 6%. State and explain whether cube A and B could be from the same material. Now, if they have same material, they're going to have the same density. That's what we are writing on. In order for us to prove that, you have 2 choices. Either you can use this 4% and the density of cube B and find the range of B. So what it's going to visually look like is something like this. So range of values for density of cube A and range of values, range of density of cube B. So when you find the range, for example, it could be that it overlaps up to this point and the lowest point at this point, and B goes up to this and comes out to this. So there's going to be a region where the values of both densities will overlap. If that is the case, then we can conclude that yes, it is very likely that both materials are made of the same density. if even after calculating ranges, if the values do not fall into one value does not fall in the category of the other one, we would have to say that no, they are made out of different materials. So what the procedure would be, you can either choose to calculate the density or the range of values for cube B or for cube A, and then check if it falls in the category or in the range of the values of the second one. So what I'm going to do now is going to use cube B to find its range. How do you do that? Is you simply multiply this number with 6% and add that value back into the value, or you subtract this for the second step. So for example, this is going to be calculated like this. So 9.2 into 10 raised to power 3 multiplied by 0.06, whatever answer you get, that gets added back into this. So that gives me a value of 9752. So the range of density of cube B at this point for me is 9752. And the smallest value after multiplying this answer and then subtracting it from this to get the lowest value, my smallest range is 8648. Now I can see very clearly that 8648 and this is 8.7, it falls in the same category, or it falls in the same range. I can find that the density of A will be somewhere along this line, or at this point. If I draw a number line, it will be somewhere along this point. Now, based on this idea, I can conclude that they are made from the same material. So we can say that since the ranges overlap, or since the value of density of A falls in the range of the density of B, they are made of the same material. So we can conclude that they are made of the same material. But you need to give a mathematical support to your conclusion. Question number 2, state the principle of moments. This is always going to be a simple definition. Sum of clockwise and anti-clockwise moments are equal about a pivot, provided that the system is in equilibrium or no external force acts on it. Part B, a solid plastic cylinder floats in water. It is used to support, and we understand the rest of the question. Now, there's one problem. The problem is, how do you visualize this? You might have some trouble visualizing this. So what they've done, there's a cylinder. At this point, it's a cylinder which is partially submerged in water, which we can't see at this stage. So some of it is under the water and some of it is outside the water, which is trying to support by buoyant force or by upthrust, so that the plank does not fall down into the water. So the part of this that is submerged in liquid is not shown in this diagram, but if you go to page number 2, you can see what it actually means. So if you look this scenario from the sides, if this is your eyes, then this is what you will be able to see. But since they're showing it from the other side, this is what you're looking at on page number 2. But then again, always read the full question, look throughout the full question to show or to understand what the full picture of the scenario might be. This might be causing some confusion, so I've clarified it, what it might actually look like. Okay, so this is the whole scenario, and the weights are given, the positions are given. What he wants you to do now is find out the distance x from pivot from A to P. Now, the weight of the person is given, the vertical force experienced by the or provided by the cylinder is given, and the weight of the beam is also given. Now, be advised that since this is a uniform beam and has a 1700 Newton weight, so I can imagine that if this is the total length of the beam, so at approximately 3 meters, there should be a force of 1700 Newtons. At point P, the force is 660 probably by the person. Yes, that's 660 Newtons, and the force given by the cylinder is 1300 Newtons in the upward direction to support this beam and the person. So we want to find out x if the whole system is in equilibrium, which means it's neither rotating, it's neither accelerating. So considering this, I'm going to write down the equation of principle of moments, but I'm going to write down that equation here so that you can understand it visually. Now, the moment generated by the person is clockwise, the moment generated by the beam is also clockwise, but the moment generated by the cylinder is anti-clockwise to support this about the pivot A. Now, the location of the pivot is important because we are going to measure all the distances from that point. So this is x, quite understandable. This is going to be 3 meters. And this is also given to you as 5 meters. So all the distances are there. Let's do that. So all the clockwise moments should be equal to all the anti-clockwise moments, or the sum of anti-clockwise moments to be precise. So let's write it down. So the clockwise moment is 660, but it is at a distance of x, which we don't know. So let's write down x, bracket close, plus the other clockwise moment is 1700 newtons at a distance of half of 6, because it's uniform rod. The center of gravity will be at 3 meters, half of 6, so this will be 3, equals to the anti-clockwise, which is this one. So this should be 1300 multiplied by 5. Now your job is to perform the algebra or arithmetic, so the x comes out as 2.12. So you can write down that answer over here as 2.1 meters. The bottom of the cylinder is submerged in water to a depth of y as shown in figure 2.2. The beam is still attached to the cylinder but not shown. So in this case, he wants you to find out the value of y. The whole scenario is given to you at this point. Now he wants you to show that the upthrust acting on the cylinder is 1400. Now notice that the mass of the cylinder itself is 11 kilograms. Now this is mass. If I want to convert this into a force, this has to be multiplied with 9.81 to make the weight of it. And there is a force of 1300 newtons. And if this is in equilibrium, that means all the force that is acting downwards on it should be equal to the upward force provided by the upthrust, which means if it is in equilibrium, which means the downward forces should be equal to the upward forces. By this logic, we say that the upthrust must be equal to the weight of the block itself, of the cylinder itself, and whatever it is experiencing from the outside. So this is 11 multiplied by 9.81 plus 1300. This gives you 1407.9, which up to two significant figures becomes 1400 newtons, and we have successfully shown what the examiner wanted us to do. Now, a good thing about these parts in which he says show that, or he wants you to show what values you're going to get. The main idea is that even if you were not able to solve this part, or if you're not able to figure out some things about the question, you can still use this value in the next incoming parts. That's what we're going to do. He says the water has a density of 990, calculate the depth y. Now we know that the formula for the upthrust is rho GV. Now let's try to use that formula over here. So the upthrust is equal to rho GV, and we're supposed to find out everything for the V. Now, V is the volume of the liquid that is being displaced, and the liquid volume that is being displaced by the cylinder is only that volume which is actually submerged in the liquid. The rest of the cylinder is outside. The water does not know that there is extra cylinder on the outside, so the only exposed or displaced part in the liquid is the part of the cylinder that has displaced the liquid. So I'm only interested in this part, so I will only be taking this h and this diameter for calculation of the volume of the water that was displaced when this cylinder was submerged in it. So the density of the liquid given to us is 990 multiplied by the value g, which is 9.81, multiplied by volume, which I would advise you to add an extra step to avoid any mathematical inconvenience. So let's find out v. And the upthrust we will take as 1400 newtons. Again, remind yourself that even if you weren't able to solve this part, you can still pick out value from this part. Now, when you find volume by rearranging this equation, your answer comes out as 0.144 meter cube. Now, this is not the final answer because we are interested in the value of y. So volume was supposed to be equal to the cross-sectional area for a cylinder multiplied by its height. And we know that the cross-sectional area can be found by pi r square multiplied by height, which in this case has become y. So let's replace the values in this. So this becomes 0.144 equals to pi into diameter, which is 0.78, but I know I have to divide it by 2, whole square because it's pi r square, multiplied by y. Now when you calculate y after the whole procedure, this is going to come out as 0.301 meters. So we have to write down this value as 0.30 up to two significant figures. Now these graphical parts, you can just directly copy it from the marking scheme, and you can probably make sense of that. But I like to find the mathematical equation that will lead us to the exact graphical trend and why it is the way it is. So in this situation, he says that the person starts walking from point A. In this case, he starts walking from this point and ends up walking to this point. What will be the change in the depth of the cylinder as experienced by the person or the same situation? So let's try to find out an equation that links everything together. So The depth was the variable y. And if I go back to the equation that we used here, I can rearrange this equation like this. So this upthrust was equal to rho gv, and v was calculated as y multiplied by pi d squared by 4. Now I cannot change the value of diameter, I cannot change the value of 4, I cannot change the value of pi. Rho and g are also the same. So the upthrust really has come a long way to the depth itself at this point, summarizing everything. But what is this depth being controlled by? So in the previous part, we saw that the weight of the cylinder and the force by the beam itself, or the upthrust was 1300 approximately. Now, as the person starts walking to this side, it will be applying more and more force on the beam, and that will be translated to the cylinder. And this will cause the depth to increase. So if the depth increases, it means that the upthrust will also be increasing because of that, right? So it looks like there's going to be a linear relationship. There's not going to be a curved line, it's going to be a straight line, which is why we dive into the equations to figure out whether it's supposed to be a straight line or a curved line. I will start from a non-zero value because the depth was never zero, and I will finish at a non-zero value which is higher than that, and it should be a straight line. Use a ruler and a lead pencil to do that, right? And the logic and reason behind this is this: there is no square, there is no under root in this equation, so it's going to be a straight line. It's going to be a straight line in that regard. Question number 3. A truck of mass 9400 kilograms moves with a constant acceleration. This is the key information that gives you the license and the guarantee that you can use the equations of motion in a straight line down a slope as illustrated here. He says that the speed of the object is 13 meters per second at this place and 22 meters per second at this place. They're 180 meters apart. Calculate the acceleration. Very straightforward. So v square equals to u square plus 2as. Mind you, you can use the equations, other equations of motion that involve time, but in them you have to find the time first, and then you can find the rest of them. But we don't do that over here. We can just, for 2 marks, let's dive into this equation straight away. So this will be 22 square equals to the initial velocity, which is 13 square, plus 2a. Acceleration is what we are trying to find out, so the distance is 180. When you rearrange this equation to do the appropriate algebra, this comes out as 0.857, which becomes 75. So this becomes 0.88 meters per second square, and I will be using this value in the next incoming parts if I have to. Determine the gain in kinetic energy of the truck between A and B. So if it's the gain, it's really the change in the the kinetic energy. So we can find out the change in kinetic energy from between point A to B. This will be half mva square minus half since the velocity at B is higher, let's do it this way. So vb square minus va whole square. You might try to do this directly in single step. Now mind you, the half m is common in both situations, but be advised that vb square minus va square is not equal to vb minus va whole square. This is the mistake that you generally do, so please be advised. I always advise you to write the formula full first and then take out the common, even if you are really good at this subject. So m into then vb square minus va square, and now let's replace the values. So this will be 9400 into 22 square minus 13 square. You get the answer as 1.48 in this example, 1.48 into 10 raised to power 6 joules. So this will be 1.5 into 10 raised to power 6 joules. There's another way to look at this, and that is from the work done perspective, which is force into distance, and instead of force we can use ma multiplied by d. Mass is 9400, acceleration was 0.88, and the distance covered in the whole process was 180. You will get the same answer doing this procedure as well. Part B, a short time after passing after B and R, you can read the same question yourself, and the momentum is given to you, the graph is given to you. The force now is defined as rate of change of momentum, and the idea is that the derivation comes from this part, that F equals to ma and mass into V minus U divided by T. This becomes mv minus mu divided by t. Mv minus mu becomes the change in momentum, and t is the time taken for the whole process of the acceleration to take place. So this becomes delta p divided by delta t. Hence, the resultant force generally, or the force generally, becomes equal to delta p divided by delta t. That is why we say that this is rate of change of momentum. The proof is also included in my A1 playlist, so please do check them out. Show that the average resultant force F is acting on the truck between t0 to 15 is this. Now, you might get confused because it's a curved line, but no need to worry about that because he's asking himself that this is an average resultant force. So what we can do is just pick out the values. This one is 21, and for the first 15 seconds, this one should be 2.5. Don't forget that this is 10 raised to power 4, so this and this is happening between 0 to 15. So the force is equal to change in momentum divided by change in time, which will become 21 into 10 raised to power 4 minus 2.5 into 10 raised to power 4 whole divided by 15. When you do this, your final answer comes out as 1.2 into 10 raised to power 4. Now, please be advised that since we're looking for the change, this was your final momentum and this was your initial momentum. What I've done is I forgot to exchange their positions. That's why we're missing out a negative sign. So for this negative, you're going to change their position. So final momentum was less, initial was high. If you do that, your negative final answer will be negative. This is Newton's, and we've successfully shown what the examiner was wanting us to show. Now, in this part, he says that identical truck S, which means that the mass will be the same, has the same initial momentum as truck R. Their truck experiences a constant force equal to F. Now, this time, the truck experiences a constant force. If I were to draw this graph over here, I am not sure about the values yet, but if I were to draw the graph here, it would be a straight line, either like this, or like this. It will not be a curved line that's given in the question. This is not constant force. Now, state and explain whether the truck S will take more, less, or same amount of time to come to rest as truck R. Now, since they have the same initial momentum, we can use the formula F equals to change in momentum divided by change in time to find their times. But we only need to do this for truck S. Why? Because truck S is not given, but the truck R is given on the diagram, and I can see that it comes to rest at approximately this point, which is 23 seconds. So it took 23 seconds to stop. So we will mention this, that R takes 23 seconds according to the figure 3.2. S takes this time. Now show your calculation by taking T over there and bringing the resultant force over there. So the initial momentum is going to be the same. They need to be stopped. So the whole momentum has to go away with a force of 1.2 raised to power 10 raised to power 4. This comes out of 17.5 seconds. So S stops in 17.5. R takes 23 seconds. So we can conclude that S stops early. And if I had to draw this diagram or graph over here, so this will be 16, this will be 17. So I would use a straight ruler and draw a line from this point to this point, a straight line, because he says it experiences a constant force. Okay, let's keep on moving to the next part. This is question number 4. It's very rare for the examiner to give you a question that is based on how stationary waves are formed, but it's a nice thing to see at this stage because they are asking these questions again and again. And this is a heads up for you to make this chapter, or at least revise this chapter to the best of your knowledge. Now he says there's a microwave emitter, and by the looks of the setup, I can see that it's going to be a stationary wave question. So the line XY perpendicular to the metal sheet, the device emits microwave frequency, okay, blah, 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 everything's fine. When the device is at position P, a stationary wave is formed, okay, good. How is it being formed? Now, please be advised that the method is very, very simple. The emitter emits the wave first, and the wave travels towards this metal plate. We're using a metal sheet because microwaves can reflect back from them. When the same wave that we sent out gets reflected back, and we haven't switched off the power supply or switched off the microwave emitter first, this wave is also incoming and this wave is also coming back by being reflected. Now, when this original wave gets superimposed by the reflected wave, since they're coming from the same source, they have the same frequency, they have same speed, wavelength, everything is exactly the same. When they meet at a point and they overlap and they superimpose, a stationary wave is formed. Now, the guarantee for that stationary wave is that we have nodes and antinodes forming at this position. Now, if we can move the transmitter forward and backward, and it receives the information as well. It's a tester as well. We can confirm where the amplitude is maximum, where the amplitude is minimum, and then we can figure out that, okay, this is an example of stationary wave. So first, there needs to be an original wave. That same wave has to be reflected. Then they need to undergo superposition, and as a result, a stationary wave will be formed. So 4 simple steps, which I've summarized here. The transmitted wave gets reflected back, very important point, because they both have to meet. The incident and reflected wave undergo superposition by meeting at a point, and places where the resultant of those two waves, the amplitude is maximum or is high, we find a node, we find an antinode. This will be antinode. And wherever places the resultant amplitude is 0, we find a node. So for a stationary wave, this is what's supposed to look like for the original wave. This is what the reflected wave might look like, flowing through each other, and the result of them is something like this. So the points which are not moving are called the nodes. These are all nodes. And the points that are moving, for example, these are vibrating from their mean positions. These are called the antinodes. Antinodes are formed when the reflected wave and the original wave, wherever they meet, produce a constructive interference or are interfering constructively. So again, that's a different debate, but this is how you write down the answer for this one, for 4 marks, right? Calculate the wavelength, very simple. V equals to F lambda. Velocity, again, it's not given in the question, but since you know it's a microwave, all electromagnetic spectrum waves have the same speed, which is 3 into 10 raised to the power 8. The frequency probably was given in the question, which is 6.3 gigahertz. So this will be 6.3 into 10 raised to the power 9 into lambda. When you find lambda, this is going to come out as 0.048 meters, which you're going to, of course, write it down over here. Now, part 2. At point P, the receiver detects a maximum amplitude. Now, this information is very important. Please be advised to note this information down, because this will help you figure out where the nodes and antinodes are going to be. So he says at point P, the receiver detects a maximum amplitude. So let's go back to the diagram. So over here, it's a maximum amplitude. So I can expect that this will be an antinode position. And then he says that the devices move slowly towards point P along the line XY. The receiver detects a minimum and maximum amplitude. The first minimum amplitude is detected at point Q. If the amplitude is minimum at point Q, then this must be a node. So if I were to draw this, for example, then this is going to look something like this. Like this. And of course, I can continue down the line like this and make the rest of the stationary wave. But at this location, it's supposed to look something like this. So now he says, determine the distance between P and Q. Now notice that this distance, PQ, the distance between PQ, looks like just quarter of a wavelength. Since I found the wavelength in the previous part, which is 0.048, what I can simply do is 0.048 divided by 4. This is 0.012. This format question is very, very common. The intensity of the microwave emitted by the device is increased. Now, the intensity is generally the power, right? Power per meter square. This has a low intensity. This has a high intensity. So it's just the amplitude that changes. It will either get more bright if you could see it, or it's going to get less bright if it's less intensity. So over here, we're not changing the frequency. We're not changing the speed. We're not changing anything else. The device is moved slowly from line X to Y and point P, Q, until the next maximum amplitude is detected at point R. State and explain whether the distance QR is greater, less than, or the same. It's going to remain the same because we're not changing the wavelength. It's still, if the frequency is the same, you calculate the value again by V equals to F lambda. You're going to get the same answer of lambda again. And even if there is a point R on the table, let's say over here, where you see that the amplitude is increasing again, the distance between node and an antinode does not change because the whole wavelength has to remain the same, right? Okay, that's why the distance is the same, because it depends on the wavelength and not on the intensity. Question number 5, a CRO-based question, microphone placed, a loudspeaker. Okay, fine. The time-based setting is given to you. He says determine the wavelength. It's going to be a longer part because we're going to use the formula, which is V equals to F lambda. And now the velocity is given, wavelength is supposed to find out, but frequency is not given. And frequency is equal to 1 divided by T. where do we get the value of t from the graph? So what I would do, I could have selected from this point to this point. I could have selected from, let's say, this point to this point, but I'm not really convinced by these coordinates because they are not passing from the points exactly. What I have done is I'm starting from this point. So this is 1 centimeters, 2, 3, 4, because it is mentioned, 5, and then to this point, this looks like 5.8. So the time base over here is 5.8, not seconds, but boxes, right? Or divisions. He says that the time on the CRO is actually represented by this. So each box represents 5 into 10 raised to the power minus 4. If each box is representing that, then the total time can be calculated as 5.8 multiplied by 5 into 10 raised to the power minus 4. So keeping that in mind, I'm going to write everything down directly into this equation. I'm going to plug the values directly. So this is going to look something like this. So V is equal to F lambda. V is 330. Frequency, since it's 1 over T, will become 1 divided by 5.8 divisions or boxes into 5 into 10 raised to the power minus 4, bracket close, into lambda. And you will see that you will have to take this to the other side to get multiplied. So this lambda comes out as 0.96 meters, 0.96. The loudspeaker now moves in a straight line while emitting the same loud sound by same sound of constant frequency. The period of the trace of the increases continuously. If the period is increasing, what does that mean? What is it going to look like on the screen? The period is increasing. So that means that this time frame that we have is increasing. So it's going to be like this or like this. So the wave that we have on the screen right now, since its time frame is increasing, is going to look something like this. So for example, if I draw this, it probably would look like this. The time between the crests and the troughs is increasing. Now, if the time is increasing, the frequency is decreasing. It's one way to look at this. And if the frequency is decreasing, that means that the object is moving away from you. So for example, if this is the observer, this is where you're standing, and there is a source of sound coming towards you, the frequency when it's moving towards you, you hear a higher frequency. But when they move away from you, you hear a lower frequency. This is Doppler effect. So increasing the period, explain your situation completely. Increasing the period means the frequency is decreasing, meaning that the speaker is moving away. Now this gets you first mark. Now he says it increases continuously. It's not that it's a higher value but constant. It's increasing. Now if you use the formula for Doppler effect, which is F heard is equal to F naught into speed of sound divided by speed of sound plus minus speed of the object, you see it produces a constant answer. But what if the object is moving continuously, ever faster or ever slower? This value keeps changing, then this value keeps changing, and this is what is shown on the screen, that it is increasing continuously, which means that the object is not moving at a constant speed, it's moving at an acceleration. That is why we conclude that since it's changing continuously, it must be accelerating while it's moving away. I know that it's moving away because the frequency is decreasing. All right, cylindrical copper wire P. I feel like this question was not related to concept, rather mathematical working. That are you good at maths or not? So everything is given to you in the question. I'm not going to get into the values first. So he says calculate potential difference, which is V equals to IR. The current is 0.85 and the resistance is 3.3 milliohms. Don't forget about the prefix, which is -3. Now, once you do that, your final answer comes out as 2.805. So this will be 2.805 into 10 raised to the power -3. So writing down 2.8 into 10 raised to the power -3 volts. Show that the cross-sectional area is this much, no problem. So resistance is equal to rho L over A. Since he's only asking about the cross-sectional area, I don't have to replace pi d square over 4. It's not the problem. So the resistance is 3.3 into 10 raised to the power -3 equals to rho is given to you as resistivity in the question, which is 1.8 minus 8. Multiplied by the length in the question is given in the diagram, which is 0.24. divided by simply the cross-sectional area A, which we don't know. So when you calculate A, it comes out as 8.33 into, sorry, not 8.3, but yeah. So it comes out as 1.30909 into 10 raised to the power minus 6 meter square. And up to two significant figures, this will be 1.3 into 10 raised to the power minus 6 meter square. And as we have shown what the examiner says, so write down shown in the bracket. Show that the number of charge density, now charge density carriers is this. So what he has done in this situation is he has given you the total number of charge carriers in this conductor, that how many number of electrons or positive charges are present who are going to help you with the conduction of electricity, which is 2.6 power 22. He wants me to calculate the charge density per meter cube. So it's going to be something like this, that the total charge or the total charge carriers divided by the total volume. That will give me the density, that per meter cube, how many electrons do I have? So the total charge carriers given in the question is 2.6 power 22 divided by the volume will have to be calculated by the cross-sectional area, because it's a cylinder. We have the cross-sectional area given in the question, we have the length, so I can simply just multiply these two values together. So this will be 0.24 multiplied by 1.3 into 10 raised to the power minus 6. When you calculate this properly, this is going to be 8.33 into 10 raised to the power 28, which can be shown as 8.3 into 10 raised to the power 28 per meter cube. So if I were to cut out a piece of 1 meter cube of this material, it will have 8.3 into 10 raised to the power 28 charge carriers to do that job. Calculate the average drift speed of the charge carriers. So we have to resort back to the formula I equals to NAQV. So current was given to us as 0.85. Charge carrier density is 8.3 into 10 raised to the power 28, calculated in the previous part. And then we have the cross-sectional area. This is 1.3 into 10 raised to the power minus 6. We have the charge, standard charge, 1.6 into 10 raised to the power minus 19, given the data booklet. And this is the drift velocity. The drift velocity comes out as a very small value, which is 4.9 into 10 raised to the power minus 5 meters per second. So 4.9 into 10 raised to the power minus 5. Right. Part C. Now, this is also a repeated part recently. They generally didn't used to ask this question, but this is an interesting bit. So he says that there is another wire made of copper. So he wants you to think that the charge densities, the densities and the material itself is exactly the same. The value of rho is exactly the same, but it has a changing shape as we move along. So what's going to happen to the resistance of the wire? So we know that the resistance of the wire depends on rho L over A, and one key bit of information is that it has the same volume. You see, just to give you a crude example, let's not get into the changing shape, let's get into the crude example. If you're keeping the volume same, the volume depends on two things: the cross-sectional area multiplied by the length, which of course becomes the pi r square multiplied by the h, but we're not getting into that at this moment. Now notice what's happening to the cross-sectional area. It's decreasing in these two terms. If the area is decreasing, to keep the same volume mathematically, the length should increase, the number should increase. So if the area is decreasing, for example, it's decreasing from 5 to 4 to 3 to 2 to 1, if the volume is, let's say, 100, then the length or the value of length has to increase by multiplying or after being multiplied with a smaller or ever smaller number to give you the same value. So two things are happening at the same time. The length is increasing, or has to increase, it has to get elongated, while the cross-sectional area is smaller at R2. So both of these two things contribute positively to the increase in resistance. Higher length means higher resistance. Smaller cross-sectional area also means higher resistance because it's inversely proportional. So in both of these regards, or because of both of these two factors, the resistance eventually will increase. So that's what we've written now. Q will have longer length and smaller average cross-sectional area. Why do we have to talk about the average? You see, since we cannot calculate what exactly is changing, what we have done is taken the average of R1 and R2 and calculated the cross-sectional area. This is a very crude way of dealing with an example, but of course there needs to be a differential equation or an integration equation that will actually eventually give us what's actually happening in the moment that's shown on the diagram. So that's why we're talking about the average. It's a 4-mark question. Since the resistance is proportional to length divided by area, leading to a higher resistance as compared to P. Now, since the length is increasing, the cross-sectional area is decreasing, they both contribute positively to the higher value of resistance. You can write this down in your own way. It's up to you. I've just summarized the points and the theory behind it. Now, he's going to ask you about the average disk speed, about distance from X. So he says that this is where the electrons or charge carriers start their journey from, and they go to this side. And what's going to happen to their speed? Now, this is again a common occurrence recently I found. So I is equal to NAQV. First, single out the variables that you cannot change. You cannot change the charge density. You cannot change the standard charge value. You are dealing with cross-sectional area and drift velocity, because as you move away from that, for example, position, I'm exaggerating the view, this is point X, and this is R1, this is R2. If you're moving away from X, your cross-sectional area is decreasing. If the cross-sectional area is decreasing, this one, to keep the value of current exactly the same, because the number of, or the current through the wire is still going to be 0.85 amps. If it is supposed to carry the same amount of current and the cross-sectional area is decreasing, then definitely the value of drift velocity has to increase. Now, the relationship, how do I know? Is it going to be a straight line or is it supposed to be a curved line? Now, to get into that, you need to look at the equation. So let's rearrange this equation by eliminating all the variables that are constant, that are not involved in this equation. So it's only left with A and V. Either take V on the other side or A on the other side, it doesn't matter. So at the end of the day, the equation comes out to be V being inversely proportional to the cross-sectional area. Now, if the cross-sectional area is decreasing, the velocity is supposed to increase. They're going to increase their speed ever more to keep the value of current exactly the same. Since this is a non-linear graph or non-linear relationship, it is supposed to look something like this, an ever increasing average drift speed. Now, if, for example, if this had been abrupt changes, for example, to reduce the diameter of the wire, then this graph would have abrupt changes too. So it would have gone something like this, with abrupt changes graph like this one. But since it's happening smoothly, we have to show that over here in the graph. And mathematically speaking, at every single instant, for example, over here, at every single instant, if I calculate the diameter, I put that value back into I equals to NAQV. The value of A changes ever so slightly. The value of V changes ever so slightly. So since all of this is happening very gradually and slowly, that's why this is a smooth graph. Question number 7, a very simple decay equation. So this will be 222 plus 4, this will be 226. And what should be subtracted from 88? 2 should be subtracted, so this should be 86. By considering momentum, he says that stationary nucleus Q. So for example, for the sake of example, let's say that if this was stationary, the momentum before the explosion or collision was 0. And if alpha is moving toward the right side, R must be moving toward the left side. If alpha is moving up, R should be moving down. If alpha is moving towards this side, R should be moving towards this side, because they should have or possess equal and opposite momentum, because we want to make sure that the momentum, total momentum, stays 0, as is given in the question. If it's stationary, then the value of mv gives you 0. Now, since we need to find the mass and the velocities, the mass is not given in the question directly. Be advised that these are nucleuses, so we have their protons and neutrons, or the masses of the protons and neutrons, as nucleon numbers. He has given me the speed of the alpha particle, which is 1.5 power 7. So I'm just going to write it down like this. There are two ways to look at this. Either we argue that the mass 222 multiplied by U, because these are protons and neutrons, and the standard atomic mass unit, which is referred as U, is 1.66 into 10 raised to the minus 27 kilograms. You can use this value, but you will see that you don't need to do that. So I'm going to leave U as it is. Mass multiplied by velocity of R, so I don't know that. So VR plus the mass of the alpha particle, which should be 4u, 4 multiplied by the atomic mass unit. That becomes its own mass, multiplied by the velocity, which is 1.5 into 10 raised to power 7. If I add them together, this should give me a zero answer because the total momentum before and after the explosion or collision should remain the same. Now, if I add them together like this, there's a problem. I need to add a negative sign. Only then a positive and a negative value equal in magnitude gets added together to give me a zero. All right, so I need to add a negative sign here. That's why I've done that. And now another perspective of looking at this is when you rearrange this equation. You can skip this step and go directly to this idea that both momentums are equal to each other. They're opposite, but they're equal. So when you take this algebraically to the other side, the whole bracket becomes positive. So this becomes 4u multiplied by 1.5 into 10 raised to power 7. This is where students generally start the question from, but they don't know where it comes from. It comes from this point, right? That the total momentum with the positive direction and the negative direction is supposed to be equal. In this question, it doesn't really matter which direction you take as positive, which particle you're visualizing is going to the right or left, up or down. The main idea is that they will be opposite to each other. So you could have had the same equation by using a negative sign for this, but having a positive sign for this. So it doesn't really matter because you're going to end up at this location anyway. Now you don't need to add the atomic mass unit in the question because it's going to get cancelled out from both sides. Luckily, unfortunately, we don't have to deal with big numbers in this case. And now you can simply find out that the VR, or the velocity of particle r, is going to be 4 multiplied by 1.5 into 10 raised to the power 7 divided by 222. And when you do this, your final answer comes out as 2.7 into 10 raised to the power 5 meters per second. He says what quantities are conserved during the decay or the nuclear process. So the answers are written on the board. Now be advised that the total momentum, the total charge, the nucleon number, neutron and proton numbers remain the same. You can choose any one of them. And the last three examples you can see in the decay equation itself. The nucleon number, proton number, neutron numbers are conserved. The number of electrons, so the charges, remain the same. And the momentum is supposed to be the same. That is why, or that is how we have the license or the guarantee to use this change of momentum system to calculate this. That is all for today. I hope this has helped you in some way. I'll see you in the next video.